If I throw an apple up in the air and catch it, it looks like it's moving the entire time, right? But what Rolle's theorem tells us is that the apple is actually perfectly still for one moment, even while it's in midair. If a function is both continuous and differentiable over a certain interval, and the endpoints of that interval yield the same y values, then you know that there's going to be some x value within that interval for which the derivative of our function is 0. If we think of the position of the apple as a function of time, and we consider the time interval between when I throw it in the air and when I catch it, both at the same height, then this function meets the criteria for Rolle's theorem, and therefore its derivative, or velocity, is going to be 0 at one point, meaning that the apple will actually stop for an instant. The apple is stopped where the tangent line is horizontal, which in this case is at the highest point. So the apple leaves my hand with a positive velocity, slows to a stop at the very top, and then its velocity becomes more and more negative as it falls back down to the height from which I originally threw it. To see another example of Rolle's theorem, follow the link here or in the description below to a lesson from CK12.